Welcome to today's class. In today's class, I want to explain the results of the circuit I've designed so far in question 3. That is NECO 2026 question 3. That is on electricity. So after designing the circuit, I will now have that these are the results I've gotten so far. For a resistance of 1 ohm, I have a resistance of 1 ohm. For a resistance of 1 ohm, I was able to get a current of 0.84 and a voltage of about 1.3 for the voltage. So I repeat, for a current of 2 ohms, so I have current of 2 ohms. I was able to get the current for a resistance of 2 ohms. I was able to get a current of 0.6, and the voltage of the potential difference is 1.7 in my circuit I've designed so far. So I would advise you to go and check my previous posts. You will see the circuit. Now, for various values of resistance, I have these are the currents, these are the voltage or the potential difference. So you notice that the trend is as current decreases, the voltage or the potential difference increases. So that is the trend for this year circuit, for this year NECO. Now you can see that this is my initial current and this is my initial voltage. Now, so how do we get the graph? This is our result. We're plotting a graph of, I plotted a graph of V against I. V is plotted on the vertical axis and the current is plotted on the horizontal axis. As you can see, for current, how do we choose the scale? Choosing scale becomes a very big problem for students. How do we choose the scale? We choose the scale by considering the highest value here for the current. This is the highest value, 0.84. You now count number of lines, 1, 2, 3, 4, 5, 6, 7, 8. The thick lines, the 10, because it's 2 cm per 1 unit. So you can now say that you have 0.8 divided by, we can now say 0.8 divided by 8, 0.84 divided by 8, and that gives me 0.10. So we can now say 0.1. That's why I check the scale as 0.1. For this one, the highest is 1.94. How do we choose the scale? We now count the number of thick lines up to this point. Now we notice that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I cannot say 11. I can choose 11 or 10. So I can now say that 1.94 divided by 10 will give me I have 1.94 divided by 10. So I have 0.19, which I approximate to 0.2. So that's how I got this scale on this axis. For a value of 0.84, we now have 0.84 somewhere here. 0.8, this is 0.8, 81, 82, 83, 84. This one is 1.3. How do we get this? Is 1.2. Okay. Now 1.2. How do you know each line at this point? This is 1.2. This is 1.2 under 8.1234, 0.84, and you're looking for 1.3. How do we go about it? You know, I say 1.22, 1.24, 1.26, 1.28, and here becomes 1.3. That's why we make a mark here, asterisk. So this is 1.3, which is this. For this one, 0.6 under 1.7. You have current is 0.6. Look at it here. Current is 0.6, and this one is voltage is 1.7. So we now count, check like this up to this point. This is 1.6. The fifth line is going to be 1.7. So that's how I plotted this. You continue in that format until you get to the last point. Now, based on that, the graph shows that we have points, 3 points. 1, 2, 3, 4, up to close to 4 points that are in a straight line. That's the line of best fits. We have this point, is off, so we can't capture all of them. These 3 are okay. Now, as you can see, this is the line. This one is a graph. This graph is a negative slope. It's going to give a negative slope because of the shape. So that's why I choose this curve to be like this, change in V. delta V over delta I, that is V1 minus V2. Some may be asking, why can't you say V2 minus V1? I said V1 minus V2 because of the shape of the graph. It's going to be a negative value. So now I said 1 minus 1, this point here, this is my slope. You make sure that you take a large angle triangle for your slope. This is my slope from here to this point. I move to this point. That is the triangle. Now I just put a broken line, a dotted line down to this place. This is my slope here. This is my V. I can take this is my V2. This point is my V1. This is my current 2. This is my current 1. Okay. So our V1 is 4 points. We have 1.42, 1.44, 1.46, 1.48, 1.5. That is my V1, 1.5. How do we get this? 2, and this line is 2.02. That's how I got 2.02. So the same thing is applicable to this down one, 8.1. So 0.81. So I got this one. The answer becomes a negative value here. So how do we go about it? We have this formula that says, you remember this formula that says V is equal to E minus IR. This is a general formula which we can rearrange to be in this form, I plus E. The whole of this is simple. For a graph of V against I, this becomes the slope. And the slope for a graph of V against I, our slope is internal resistance. So that's how I got the slope is equal to internal resistance, which is a negative value here. So our result here is negative. Negative cancels negative. Our internal resistance becomes 0.945 ohms. So this is how to solve this. How do we get the intercept on the vertical axis? You can see this point. This is the intercept. This one is 2.01, 2.02, 2.04, 2.06, 2.08, 2.1, 12, 14, 16, 18, 2.2, 2.21, 2.22, 2.24. So our intercept is 2.24. That is the intercept in volts. Thank you.